Hey everybody, so we're going to be working on number 19 for the chapter 4 practice test. And so as you can see, we have a graph here. It says the table shows the temperature Y in degrees Fahrenheit at time X, where X is equal to 1 corresponds to 1 a.m. It says use the regression feature on a graphing calculator to find a quadratic model and the cubic model for the data. And so we are given this table of values. We don't know the actual function. We just know the values, right? So we only know this. And then it says enter the quadratic model, round each number to the nearest hundredth. So once again, we're going to need our graphing calculator. So we'll open that. And so what we're going to do is we're just going to add a table here. We're going to put add item in table. And then notice how we're given X1, Y1 as their names. And so now what we're going to do is we're just going to input those X values. So we have 6 and 8 all the way to 20. Like that. And for our Y values, we have 2, 5, 8, 12, 13, 14, 12, 10. So let me see if I can find these points. So here are my points. As we can see, my data is right here. And so the first thing we have to do is we have to use the regression feature on this calculator to figure out a quadratic model. So what if I were to place a quadratic equation or function here, which one would be the best fit? And so we have to use regression. And so we did do a few examples like this. And so the way that we do regression is we're going to use this function named y1. So what you're going to do is you're going to click on y. And without clicking on anything else, you're just going to click on 1. This should automatically put the number down here. So we have y with sub 1 is equal to, no, sorry, no, it's not equal to. We have to put our tilde, which is right, this little sign right there. And that one is right underneath your escape key on your keyboard. And so because we are trying to enter a quadratic model, what we're going to do is we're going to put the general standard form for a quadratic equation with the variable x1. And so this means that the standard form is going to look like this: a x1 to the second power plus b x1 plus c. And so now if you notice, the calculator is trying its best to put a quadratic equation and fit it along all of our points. And so what equation is that going to be? The one that we're going to need? They're going to give us the numbers right here, the a, the b, and the c. And so in other words, we can say that that function is going to look like, and then remember, we have to round to the nearest hundredth, so we need 3 decimal spots. So then my equation should look like the following: negative 0.3 spots. That means we look at this one and we look at the number next to it. So that becomes 134. Let me just double check. So 134. Yeah, we're gonna do 100. Oh yeah, we are doing 100. My bad, guys. I was looking at this one. So for the quadratic, we are looking at 100. So it's only 2 decimal places. So we look at this number and the one next to it. So we're gonna do this, x to the second power, and then we'll do plus 4.114 x to the first power minus 18.83. Right, and so that becomes the closest quadratic function that will fit as an answer. And so if you look down here, you'll notice that this is the correct answer: negative 0.13, 4.14, and 18.83. So that was us entering a quadratic model. Let's see how we're going to figure out our cubic model, which is this one down here. So to enter my cubic model, I'm going to go ahead and click on this one so that it disappears for now. Get rid of this one. And because we're still using the same table, we're going to still use the same variables, but now we have to do the standard form of a cubic function. So once again, we'll write y1. We're going to do a tilde, which is the regression feature. And now we're going to do the same thing, but with a cubic function. So x1 to the third power plus b x1 to the second power plus cx1 to the first power. So we just leave it like that, and then plus d. And so once again, you'll see that this calculator tried its best to fit a cubic function along my data set, my data points. And so if we want to figure out what this A, B, C, and D is going to be, all we have to do is look down here, right? And so this is telling me that the A in my cubic function, and now we are rounding to the nearest thousand, so 3 decimal spots. So this is going to be negative 0.008, and that's why we see this down here. B is going to be 0.1615. And so because we're looking at this 1 and the 5 makes it go up into the next number. So we see that here. Same thing for C, and then same thing for D. So again, the calculator pretty much does everything for us. We just have to input it correctly. And so now it says the final two, it says use each rounded model to estimate the temperature at midnight. So x is equal to 24. So we just said the quadratic function will look like this, so 0.13. But now instead of putting in an x, we are putting in a 24. So we'll do 24, and that's to the second power, plus 4.14. And then again, everywhere we see an x, we replace with a 24. And then we put the last value, and as you can see, it is approximately 5.65, but they ask us to round to the nearest degree, right? So that means to the nearest whole number. And so the nearest whole number that 5.6 approaches is going to be 6, as we can see right here. And then we do the exact same thing, but now for my cubic function, so the one we just got over here. And then so same deal, we're going to rewrite our model. And instead of an x, we're going to put a 24 and repeat 0.162, 24 to the second, plus 0.576 times 24, and then minus 5.833. And as we can see, the nearest whole number that this approaches has to be negative 9, which is why our answer is this. So all of the work the calculator did for us, we just have to learn how to actually use the calculator features.